Hello and welcome to part 6 of my APS tutorial. Today I want to go over the last few parts because we've only got 3 parts to cover in this video. It should be an extra short video. We've only got these 3 miscellaneous parts that didn't fit in any other category that I've covered so far. And yeah, so without further ado, hop right on in. So we got this. This is this headpiece here, which is this skimmer tip. So skimmer tip, which is this part here, what it does is or what it does that's special is, well, if you have a normal shell, without a skimmer tip, and your shell comes in at an angle that's shallower than 15 degrees and it hits water. So your shell hits water at an angle that's shallower than 15 degrees, then the shell has a chance of bouncing. It's got a chance of bouncing off the water. I don't know what exactly that chance is. It's something like 50-50, something like that. And if your shell bounces, potentially you could end up missing the opponent or whatnot. Anyway, so what the skimmer tip does is it increases that angle from that required angle from 15 degrees to 30 degrees, or at least that's what I assume it does. On the tooltip it says 15% to 30%, so I don't know if that's a typo or whether that's actually what it is. But yeah, so as far as I'm aware, it increases it from the required angle from 15 degrees to 30 degrees. So that means your shell can come in at a higher angle but still bounce. And it also increases what I've assumed is 50% chance for your shell to bounce. It increases that to a 100% chance for your shell to bounce. So if your shell comes in at 30 degrees, your shell will bounce every single time. Now, generally, that's a bad thing. Generally, you do not want your shell bouncing. If your shell hits water, that's generally because your shell was going to target something that's underwater. So either a part of your opponent that was underwater, or, so say their AI is slightly underneath the water, something like that. And if your shell bounces off the water, that you've got a high likelihood of missing the enemy altogether, which is obviously a pretty bad thing. So generally that part of the skimmer tip is pretty bad. However, the skimmer tip does have a use. The skimmer tip does have a sort of bit of a niche use for it, and that is if you come on over to the part info bit and look at this speed modifier. We've got a speed modifier of 1.75. This makes it the second fastest shell head out of all of the shell heads in the game. So it's only beaten by the sabot head. So the niche use for the skimmer tip would be if you had a chemical shell, and obviously if you put a sabot head on a chemical shell, that's going to make your chemical shell only do 25% of the damage it does normally. But if you use the skimmer tip, you don't get that disadvantage. So you don't get that that 75% damage reduction. You get your full damage, but you also get a decent speed modifier. The skimmer tip does go faster than the composite head, which is the third fastest. Which you could use the composite if you wanted to. The benefit of using the composite is that whilst it is slightly slower than the skimmer tip, you don't have to deal with bouncing off of water. But yeah, so the disadvantage is ironically the main thing that the shell does, and the advantage is just this little side effect it does, which is a bit stupid, but yeah, there you go. Skimmer tip exists. You can use it if you want. Right, these final 2 pieces are both body parts, so they go on the main section of your shell. So starting off with this one here, we've got the grav compensator or gravity compensator. And what the gravity compensator does is it will if you have a shell without a gravity compensator, and you fire it and your shell your shell will arc over to the enemy. So you're firing your shell at the opponent, and your shell is going to go over some sort of arc to get to the enemy. If that arc is relatively high, then potentially, gravity is going to be slightly lower for the shell at the top of the arc, at the peak of the arc, than it will be at the bottom of the arc, which means that the AI is not going to be able to, might not be able to aim that shell perfectly, because the AI assumes gravity is constant for the shell, so it assumes it will remain constant as the shell flies over to the opponent. So if the effect, or the acceleration due to gravity changes by a significant amount as the shell goes over to the opponent, then the AI may potentially miss the opponent altogether. 99% of the time that is not the case. 99% of the time APS shells do not have that problem, especially because APS shells tend to be quite fast. Not always, but they tend to be quite fast. Even the slower shells barely arc. Even if you've got a shell that's going like 150 meters per second, which is really, really slow, your shell's hardly going to arc. It's going to arc a little bit, but it's not going to arc much. Or not enough to warrant using the gravity compensator. But anyway, what the gravity compensator does is it makes your shell experience the same acceleration due to gravity throughout the entire time your shell is moving. So when your shell is moving through the air, it will experience the same amount of gravity. How that works, I don't know, but there you go. So anyway, so that potentially could mean if your shell has a really, really high arc, it could your shell will still potentially be able to hit the opponent. Obviously, I would not, pretty much I wouldn't ever recommend using this over have Compensator, because for the most part it doesn't. It's the benefits are so marginal and so rare. It's so rare for the grav compensator to be beneficial, but well, yeah, I mean, yeah, especially on APS shells, just because they're a lot, they hardly arc. So I personally haven't used the grav compensator that often. I've used it once or twice. It exists. You can use it if you want, but yeah, I wouldn't use it. Anyway, we've got a final piece, the final segment here, and that is the stabilizer fin. Right, the stabilizer fin is this piece here, and what the stabilizer fin does is it will reduce the inaccuracy of your shell to 80% of whatever it was before. So basically, it makes your shell 20% more accurate, which is that's half decent. And that does come at a slight cost, and that is speed. It reduces the muzzle velocity of your shell slightly. I don't know how much it reduces your muzzle velocity by, but it reduces the speed of your shell a tiny bit, which is a bad thing. But anyway, I wouldn't recommend using the stabilizer fins all too often, because generally the benefit of the stabilizer fin, which is the reduced inaccuracy, that can be accuracy can be fixed or made better in so many other ways that it's hardly worth using the stabilizer fin. You could use tracers possibly. If you were to use tracers, then the benefit to your accuracy is your accuracy doubled. It's straight up doubled, which is rather than just 20% extra accuracy, you get 200% extra accuracy, which is obviously much better. So well, not 200%, 100% more accuracy. Anyway, which is obviously much better. The stabilizer fin does have another benefit, I suppose, and that is the fact that it stacks. So you could have a whole bunch of stabilizer fins if you really wanted to make a really accurate shell. I don't see why you'd want to do that, but you could. The main disadvantage of the stabilizer fin is the fact that it takes up a segment on your shell. You know, that segment could be an extra warhead, or it could be an extra thing of gunpowder, gunpowder casing. And that would benefit you. You know, that would be way more beneficial for your shell generally, not always, but generally. Usually accuracy is not much of an issue. The other way you can fix accuracy is just to make your barrels longer. If you use longer barrels, you have higher accuracy, and that's another way of fixing accuracy. And obviously you don't have to compromise your shell in order to do that. Anyway, so that's everything now. So I've now covered every single part in the shell customizer. I've covered briefly talked about every single part in the shell customizer, which means now what I want to do is in the next episode anyway, I want to put these shell parts together. So I want to create actual shells. So I want to create, so go over the various different types of shells, possibly demonstrate the different types of shells, sort of show how they work, and yeah, how that'll work, I don't know, but we'll get there when we get there. So yeah, so that's it for this episode. So thank you for watching, and cheerio.